Today we're talking about solving absolute value inequalities. An absolute value inequality is just an inequality that has an absolute value expression in it. We're also going to be talking about absolute deviation. Absolute deviation is basically a given amount that you don't mind being above or below a certain value. So if you can imagine you're measuring angles and your teacher says, well, this angle was 70 degrees, but I will accept it if you were within 3. You could be 3 above or 3 below that 70 degrees. So to find an absolute deviation, we would take the value you had minus the 70-degree angle and make sure that we get an answer that is 3 or less. Well, it could be positive 3 above that 70, or 3 below that 70. So we want the absolute value. We're going to try a problem with absolute deviation in just a little bit. All right, an important thing to think about when you're solving an absolute value inequality is think about absolute value equations. So if I had the absolute value of x is less than 2, it's kind of similar to the equation, the absolute value of x equals 2. And this equation is basically telling us that this x has to be within 2 spaces of 0. So when I see the absolute value of x is less than 2, it means whatever that value of x is, it's less than 2 spaces from 0. So I can think about it this way. I can write 2 different inequalities. X is less than 2, or because it could be 2 going the other direction, x would be greater than, I flip the sign here, negative 2, and I change this to the opposite. So basically, anything that is less than 2 spaces from 0 fits in this inequality. Notice I have open circles here because it never said it could be exactly 2 spaces. This is a compound inequality. Here's another one to think about. So if we have x is greater than or equal to 4, we can think about a similar equation. The absolute value of x equals 4. And this equation would tell us that x has to be 4 spaces away from 0. So when I see it in an inequality, it's basically telling me that this value of x has to be more than or equal to 4 spaces from 0. So it could be 4 spaces away or more, so positive 4 or more spaces away, or it could go the other direction and be negative 4 or more spaces away. So I can basically take this inequality and write it exactly as it is without the inequality sign, without the absolute value signs. X is greater than or equal to 4, or I can flip my sign and say x is less than or equal to negative 4, and it gives me all my solutions. And once again, we have a compound inequality. So let's look at actually solving an absolute value inequality. So here we have the absolute value of 2w minus 1 is less than or equal to 11. So I can write 2 different inequalities here. So I'm going to start with the one that is exactly how it looks, except I'm taking away the absolute value sign. 2w minus 1 is less than or equal to 11. So I added 1 to each side. To get 2w is less than or equal to 12, I divided both sides by 2, and I got w is less than or equal to 6. The second inequality I set up, I reversed my sign, and I changed my answer to the opposite. So I have 2w minus 1 could be greater than or equal to negative 11. I added 1 to each side to get 2w is greater than or equal to negative 10. I divided both sides by 2, and I got w is greater than or equal to negative 5. So my values for w are between 6 and negative 5. I also use closed circles here because I do have the equals. It could be exactly equal to negative 5 or 6. So let's try another. In this one, I have to get rid of some things that are outside the absolute value before I start to solve. So I'm going to begin with getting rid of this 1. I'm going to subtract 1 from each side, and I have 4 times the absolute value of 2x minus 5 is greater than 20. And then I'm going to divide by 4. So I'm left with my absolute value of 2x minus 5 is greater than 5. So I can set up two inequalities here. My first one is going to be exactly how this looks without the absolute value symbol. So 2x minus 5 is greater than 5. So I'm going to add 5 to each side, and I have 2x is greater than 10, divide by 2, and I get x is greater than 5. My second inequality is going to start exactly the same. I'm going to start with the 2x minus 5, but I'm going to reverse my sign, and I'm going to change my answer to its opposite, negative 5. I'm going to now add 5 to each side, and I get 2x is less than 0, divide by 2, and I get x is less than 0. So in both cases, it's not equal to 5 or 0, but x can be less than 0. So I would shade going this way. Or x can be greater than 5. So once again, an open circle, and I would shade going this direction. Let's take a look at some absolute value inequalities with special answers. So here I have the absolute value inequality. The absolute value of 8x minus 11 is less than 0. Well, an absolute value is always going to be greater than or equal to 0. We can't get an absolute value that is less than 0. So I really don't have to do any work here. There's nothing that's going to fit in that x and make it less than 0, so no solution. When it's no solution, I don't graph anything on the number line because nothing here is a solution. On this one, I've got 10 minus m is greater than or equal to negative 2. Well, once again, an absolute value is always going to be equal to 0 or greater than 0. So this is always going to be greater than negative 2. So my solution here is all real numbers. Everything here can be a solution. All right, so here's that absolute deviation problem that I talked about. So you're buying a new computer and you're willing to pay the mean price with an absolute deviation of at most $100. We want to know how many of the computer prices meet your condition. Well, it's all based on the mean. So the first thing we have to do is find the mean. So I took all of these computer prices and I added them up to get a grand total of $6,640. But that was for 10 different computers. So to find the mean, after I add all that up, I divide by 10. So the mean price for these computers is $664. Okay? Now I am willing to pay an absolute deviation of at most $100. So $100 above this price or $100 below this price. So when I set up my absolute deviation equation, the price I'm willing to pay, if I subtract the 664, the absolute value of this has to be less than or equal to 100. So this price that I'm paying here minus that mean has to be within $100 of this of 664. So let's actually try some values here. So I can set up two inequalities. X minus 664 is less than or equal to 100. This is basically the same inequality minus the absolute values here. And I can add 664 to both sides. So I'm willing to pay something that is less than or equal to $774. I can also set up x minus 664 as greater than or equal to negative 100. So I'll add 664 again to both sides, and I'll get x is greater than or equal to 564. So the price of computer that I am willing to pay for is somewhere greater than or equal to 564, but equal to or less than 764. Excuse my error there. 764. So it's between these prices and including these prices. So I'm looking for things that are either equal to 564 or equal to 764, or between them. So 890 is out, 650 would work, 660 would work, 450 is too low, 725 would work, 750 would work, 370 is too low, 670 is in that range, 650 is in that range, and 825 is too high. So how many of the computer prices meet our conditions? 6.